Greetings and welcome back to the Tennessee Small Farm Expo. I'm Dr. Reginald Archer. I'm an assistant professor here at Tennessee State University in the Department of Agricultural and Environmental Sciences. And today I'm going to be talking to you about collecting spatial data with your smartphone or smart devices. So we're going to be talking about GIS and Geographic Information Systems. So GIS is Geospatial or Geographic Information System, and what we do with GIS is we think of it as the science of where and studying all the questions that have to do with where. And what you see on the screen is just a word cloud of a lot of the various areas that I do work in, any type of spatial analysis, mapping, global type of research. We use drones. We look at environmental change. We use the Internet of Things to bring data together. We look at the changes in land, species identification, and species habitat, water restoration, various types of data. So these are just some of the things that we do at the College of Agriculture at Tennessee State University. When we think about GIS, again, like I mentioned, we talk about the science of where. And GIS can answer 5 basic questions. One, usually the first question we ask is, what is at a particular location? Remember, geographic means location. What is at that particular location? Where is this particular feature? What has changed in a certain time or in a certain time frame? What spatial patterns exist? What if types of questions, so we can do simulations and model what if scenarios. The different types of tasks include inventory, monitoring, of course, inventory and monitoring together, and spatial analysis, as I mentioned, and modeling and simulating different environments, predicting different outcomes. GIS is pretty powerful because it allows us to ask those questions that we just talked about, but to ask those questions using a database that we develop with layers of data, layers of information. And then we perform spatial operations on that data to generate some type of geographic output or graphic output, like a map. And sometimes it can be pretty tough to do manually if we had a bunch of paper maps, but we can do that digitally with not too many issues. So what is it? It can be defined as integrated software systems for handling of what we just talked about, the geospatial information. Collecting, acquiring the data, storing the data, transforming the data, and doing analysis with that data. Now that we have all the data in our system, how can we use it to explore the various patterns or do the modeling or do the predicting analysis? And then we can visualize the data once we're done. We can visualize the outputs in terms of maps. Those could be digital maps. Those could be printed out on paper. We can look at the maps on our smart devices, on our phones, on our tablets. Any task that you might want to perform with geographic data, we can pretty much do that with Geographic Information Systems, GIS. And when I talk about geographic data, I'm thinking location, location, location. Any location-based devices, anything that has to do with location. Remember, we're talking about where. We can do analysis in a GIS or with a GIS. When we use data in a GIS, one of the things that makes it different from various types of maps is we can develop layers of certain types of data. So in agriculture, we might have a soils layer, we might have an elevation layer, we might have a layer that is each layer is a particular crop. Okay, we might have a layer that is just the roads. We might have a layer that is the buildings, hydrology, geology, water bodies. Each of these can be a layer, and they all are linked together by georeferencing system or coordinate system. And that, when you look at this line that goes through this data, you can imagine all these data layers that are all tied together at the same point on the ground. So what can you do with GIS? In agriculture, of course, we can do lots of things with GIS, but we can map where things are. We can map quantities of data, where, or I'm sorry, how much of a certain type of data do we have? How many is in the particular location? Is it more here than it is in someplace else? What is inside a particular plot? What's nearby that plot? And then we can map change over time. So lots of different things that we can do with GIS, and this is just a small list of what we can do with GIS. GIS is a pretty powerful tool, but today we're going to be talking about what you can do with your mobile devices, of course. So you want to ask, does GIS work for you? Of course, we know we can map various issues. We can look at relationships between different features on the ground. We could look at regional impacts. We could look at a particular location, and is this where I want to concentrate my work? Right? Do I need fertilizer in this area but not in another area? So you can assess where to concentrate your efforts, and it just helps you to better understand the area or the community that you're working in. For an effective GIS, of course, you need hardware and software, but more importantly, you need good data. And you need a method to analyze the results of your work. So if you create some maps, you want to be able to analyze those maps. But one of the questions that we have is, do you need to be an expert user? And the answer is not really. You can be an expert user to do some of the expert applications that GIS has to offer, but you do not have to be an expert to use GIS applications, and I'll show you in a moment what we're talking about. So one of the ways that we collect data is by using our mobile devices. In this case, we can take software like ArcGIS Collector as one potential solution. And this software allows us to create a map, and we can tell the map the kind of data that we want to collect, and then we can just go out with our devices and start collecting that data and inputting all the fields. So if it's crop data that we're looking at, we want to do a crop inventory, we can input all the attributes of those particular crops into our data set. And this is great. If you have access to the software, if you would like to pay for the software because some of it is not free, then this can be a good solution for you, a very good solution for you, because you can do a lot with it. You can collect the data, several people can collect data at the same time, and it all can pop up on the map real time in one central location. So one map, lots of data collectors, and collect a lot of information. And you can do it all from your device. You can create maps, you can edit various data points, you can delete points, you can create lines and polygons. For example, you see this is a historic building, and you can use the app to build the outline of the building or whatever building's on the field. If we wanted to, we can also take that data and we can mark out those each tree on the property. So we can see trees on the property here, and we can label those as well. Again, multiple users. You can also attach pictures to your files, and then we can look at the data real time. But that's Collector, and you may have to pay for some of the features. Many of the capabilities are not free, but I'm going to talk to you specifically today about using MyMaps. MyMaps.google.com is another option to be able to collect data for free. And all you have to do is go to mymaps.google.com. If you have a Gmail address or Google account, you can just sign in and you can start to go to work creating maps. So this is just an example here. And go to MyMaps. You can see that you can start to create maps, and you can, let's say we want to work on this particular plot of land, and we want to collect data around the crops that are in this particular plot of land. This is just an example that I'm using on the TSU main farm. Okay. One of the things we might have a table or an attribute table, a list of all of our crops in a particular plot, the different varieties, nitrogen rate, photosynthetic output, and we might want to collect data around a certain number of plants. So we might create this table beforehand and just start filling it in. As we go to each particular plant at a location or a particular crop, particular tree, we can then collect data on our devices, or we can write the data down, or we can fill in a spreadsheet like this. And then that data can be converted into a GIS compatible format from that spreadsheet. And I'll show you how to do that in a moment. But that's one way to do it if you're collecting the data manually. Another way to do it is to create the spreadsheet, empty spreadsheet, and to bring the spreadsheet into MyMaps so we can use that and fill in the data as we go with our devices. So how do you use MyMaps? Well, the first thing you want to do is once you open up MyMaps and you sign in, then you can just create a new map. And you can do this on both your tablet or your laptop or on your mobile device. So I have both examples here. So you can see a mobile device here. There's a little plus sign. On a desktop, you might see it create a new map. And this is available both in PC and Mac, Windows environment, Android environment, unlike the collector and some of the ArcGIS characteristics that are only available to you on PC. So the first thing you want to do once you create your map, of course, you want to zoom into your area of choice. You can put an address in this address bar. You can put in a location. You can zoom in and out of your location using the plus and minus symbols here. You can add a title to your map. Currently, this is an untitled map. And then you can start to add layers, and you can name the layer, and you can import data. So one of the things I mentioned was creating a spreadsheet initially and then importing the data. Or you can import the spreadsheet and then you can fill it in as you go. So once you zoom into the area of choice, then you can start to develop the map. So here is my area. Again, this is the TSU main farm. I've titled this a small farm or TSU farm demo, small farm expo demo. And I've created a couple of layers here, my farm and some crop data layer. But this doesn't show me the land underneath. So I'm going to change the base map. And the initial base map is typically what opens up as you see the screen here. And I'm going to change that to a base map where I can actually see what's on the ground. So you do that by clicking on this little arrow next to the terms base map. Once you do that, you get some options. Here I select the satellite image option, and that lets me see the actual ground. Of course, now once I have my map, I have my title, I have the layer I want, then I can just start adding points. And it's really just that simple. I can do this with my device. If I'm on the ground, I can actually go to a location and start collecting data there, or I can do this using a satellite image. If I know that the satellite image is up to date and is ready for me, or is the most up to date and represents what is actually there on the ground, then I can use that to collect my data as well. So all you have to do is click on the little symbol that is for add marker. This arrow is pointing to it here, and you just have to click on it once. It won't look like anything happened, but then you'll have to put your icon, your marker, at the location that you would like. So let's say we want to collect some data on one of the plots. Then I can put a pin or that marker right over here in one of these points. Let's say there's some trees there or some other type of crop, and this dialog box will pop up. I'll get to put my point in that. I'll label it, and then I can put a description in this dialog box, second box here. And then I just hit save, and I've just collected data. You can add your own points, as I mentioned, directly to the map from your device. Or if you want to import a spreadsheet, you can just click on this import button here, and you can import a CSV file, a spreadsheet, or a KML file. And we'll be creating a KML file with this data, but you can also import a KML file. So we're going to collect some data right here in this plot. One of the other things that you can do, like I said, if you create an empty spreadsheet where you know the kind of data that you want to collect, in this case we want to collect the plot, the variety, the nitrogen rate, the photosynthetic output, and then of course latitude and longitude. What happens with this data is once you create your attributes in your table, you load it up, then you can just start to fill this in as you go. So for each of these points, one of these can pop up and I can just start to label the information that I need. And the cool thing is it will provide the location for me. Of course, if you don't have that table set up, then you can input it here. I can add the crop and label name. I can enter each of the attributes, and I can do that separated by commas or semicolons. And I can do the same thing, whether it's on my device or on PC. And don't worry, if you make a mistake, there is a back arrow. Just click on that, and it's like an undo button. The other thing you can do aside from collecting points is you can create a polygon. As you can see here in this smaller image, you can create a polygon around an entire plot. So this is the rectangle or the size of the plot. I can then calculate the area. It will provide that for me, the total area or the perimeter around that plot. So if that's something that you want to measure, you can do that using this symbol here, where I can add line or shape, and it'll give you the options of shape, where you can add lines until you connect the endpoints, and then that will give you a polygon shape. Or you can add a route, a walking route, a biking route, or a driving route. One thing I will say, if you use any of the routes, then it will only allow you to add that on a road or a surface. You can also add pictures to your map. So you can go back to your pin, click on the camera icon. So here's my pin from my point 11, and I can just click on this camera icon. This I can do on my device, or I can do this regardless of how I import the data, I can still use this camera to add a picture. Then I can just drag the image into here, or select an image from my computer. Here it is on my smartphone. I've collected the image of an apple tree, and I add it. So here's a Fuji apple tree. It's about 8 feet tall, has about a 2-inch trunk and a 5-foot canopy diameter. Once the picture's uploaded and my attributes are here, then I can just click the blue button and save it. And then you're done with that particular marker or this data collection for that one particular point. And it's just that simple. And then move on to the next point, and then the next point, and then the next point. There are even various icons that you can change. Here's an icon of a tree. So you can change those label markers or icons in order to whatever fits for your particular map. You repeat this process until you have all your points. And here in this particular case, this is me filling in all the data for the data sheet that I created called crop data. I can also use the same if I added all these points one by one without a spreadsheet, and I can do that as well. It wouldn't be called a CSV file. But either way, once I collect the data, I can use that in order to move on. I can export the map as then a KML file. And here's the export map to KML. Those KML files can be opened in ArcGIS, Google Earth, and other applications. You can get the coordinates then and add them to your spreadsheet. Here are the coordinates right here, and I can just add them to my empty spreadsheet and use them here. Once I have a spreadsheet or a KML, I can import the data into ArcGIS Online if I wanted to. And you can create a free account to use ArcGIS Online. I can go to arcgis.com and just click on Map, and I can start to add my data to the map. Here I can add layer from a file, and I can add my CSV file here. Add layer from file. Here's my cropdata.csv. then I can import the layer. Once you click on import layer, you'll see the data will pop up, and it will give me some options on what attribute I would like to map. So in this case, I would like to map the photosynthetic output, and the size of each circle is the value associated with that photosynthetic output. The thing I like about ArcGIS Online, and this is again still the free version, that I can go in and zoom in even a little bit further than I can with the Google Maps or My Maps. Here I get various options. I can change the colors and different symbols, and I can also change the attribute that I want to show. If I want to show the nitrogen, then I can do that as well. So there are lots of uses for the mobile devices. Smartphone GIS trends will continue to evolve, and there'll be other options for you. I've shown you, just quickly talked about ArcGIS Collector, ArcGIS Online, and using Google or My Maps, which you can also import into Google Earth Pro. And you can add other layers in each of these software items. You can add other layers of data as well. So thank you. Here's my contact information. I'm looking forward to your questions.